and welcome to MN 234. This is the review for the final exam for Metallurgy. The goal of this lecture is to go through the Metallurgy review PowerPoint, which is all of the PowerPoints that we've looked at up to this point. I just shoved them into one folder or one PowerPoint anyways, and I didn't clean it up, so it's a little bit messy, meaning the format is not clean, which you'll see that when we flip through it. So the other thing is I'm going to give you a bunch of tabs, pages to tab, topics to review and understand. There will be some application questions on the exam, just like there was on the midterm, meaning that using the iron carbon phase diagram, if I give you a steel and I heated it to a temperature and I cooled it at a certain rate, what is the microstructure going to be? So there'll be some questions like that. So we'll look at the iron carbon phase diagram, just kind of a little bit of everything. But I'm going to go through this PowerPoint, which is 96 slides or something like that, and which seems like a lot, but we've already went through every one of these slides throughout the semester. So as you can see, I'm just kind of rolling down through some of these things. When I'm going through the review, I'm going to say that's not on the exam. I'm not going to ask you about hypo, eutectoid, and hyper-eutectoid. It's right on the bottom of the iron carbon phase diagram right here. So I am not going to ask you about that. There will be some other things like the isothermal transformation diagrams are not on the exam. So there'll be things that I'm saying this is not on the exam, and there's things that I'm going to say that, you know, make sure that you understand how to use this, because this will be on the exam. So that's kind of the goal, is to give you a more precise idea of what to expect on the exam, what topics, and pages to tab in your book, along with all of the other pages that I've told you through the semester to tab. But I'm hopefully should get to all of the pages that you should tab in your book that will significantly help you find things. Like page 25 is rolling direction. There was questions on the midterm about that. There'll be questions on the final about that. So kind of rehashing everything as I go down through there. I will be posting a separate audio of the format of the final exam and how that's going to go. So what to expect as far as the test taking. Obviously it's going to be open book, it's going to be online, but I will have a separate audio outlining more information on that. Metallurgy, the study of metals, going back to page 1 in our textbook. Early on in the chapter 1, it talked about different types of metallurgy: extractive, mechanical, physical, and welding metallurgy. I might ask about the definition of metallurgy, but not each of those individually. Everything on this page right here, understanding the terms of metals, alloys, ferrous, non-ferrous, and then especially chemical analysis, knowing what each of those are is very important, because as you read through the questions, these will be terms that we'll be using, and you got to be able to understand these terms to be able to understand the question. I might note, we talked about temperatures and changing temperatures from Fahrenheit to Celsius and Rankine, and there will be no conversions on the exam. You will not need a calculator. I did give you some numbers for density. I won't ask about those on the final exam, although they are good things to know. Melting points, we talked about melting ranges and understanding that there's a melting range instead of a melting point for most of the alloys that we're using will be helpful. Some more terms there. There are very few term questions on the exam because you can just open the back of the book and look at them under the index or glossary. So Very few, if any, definition type questions. Again, here we have temperature measurements. I think everybody knows what Celsius and Fahrenheit is. I won't be doing any conversions on the exam. Chapter 3, why do we do mechanical testing? That would be a good one to be able to answer. Knowing the types of loading, tension, compression, shear, torsion, and bending, on page 24 in your book. Be able to list them and understand what those are. And then on page 25 is rolling direction. I would definitely have that page tabbed. Remember, we talked about 3 rolling directions, right? There is longitudinal, transverse, and through thickness in that order. Longitudinal has the best percent elongation, the best fatigue life, and then transverse direction, which is perpendicular to longitudinal, that has the second best percent elongation and ductility and fatigue life, and then the through thickness, which is the thickness of the sheet or the plate that we're working with, in the Z direction. For those of you who do a lot of CNC work, the through thickness is the worst by far as far percent elongation and fatigue life and ductility. And in a lot of cases, we want to avoid putting our through thickness in tensile loading. Actually, in the welding code books, it's against the code to put plate, like steel plate, in through thickness tensile for a structural application. That's how bad it is compared to the other directions. So tab that page, be able to answer some questions about rolling direction. Reaction to forces, stress and strain. You should know those intimately. What is stress? What is strain? And then the stress strain curve. What does it represent? The stress strain curve really represents the mechanical properties of the part. I'll come back to the percent elongation. So when we look at a stress strain curve here, we have lots of information. The slope of this line right here, which you could do rise over run here, the slope of that line is the modulus of elasticity, which we didn't talk about, but you read about in the book. That is a mechanical property. We have the highest point on, I'm looking at this ductile curve here, the highest point on this ductile curve is the ultimate tensile strength. We have our breaking strength, our point of failure. We have our how much ductility we have by how far our component stretches or strains. We have, if I take the area under the curve here, this is the toughness of the material. So this really represents our mechanical properties. We can derive almost all, if not all, of our mechanical properties off from a good stress strain curve from a given piece of material. On page 28 in your book, it starts talking about toughness testing, which toughness is the area under the curve here. So know the difference between toughness and strength. When we're doing mechanical testing, how does our test conditions like temperature, environment, grain direction, which I just talked about a little bit on page 25 in your book, preparation of specimens, we talked about having nice clean surfaces and grinding marks and the surface finish, all makes a difference in how our part is going to fail. We talked about fatigue life. Fatigue life is the #1 failure of metals in service. That's the #1 reason why metals fail is through fatigue. So I mention that once in a while, like I said earlier, that the longitudinal direction is going to have better fatigue life, and then traverse, and then through thickness, which is not listed here or in the book, but we talked about it, we need to know about it. Our through thickness has the worst fatigue life. Why is that important? Because that's the number one reason why materials are going to fail. So when we design and build stuff, having that in mind, so knowing which of these directions we're loading the component in, or designing it so we're loading it more in our longitudinal direction than in the other two. If that's possible, that's what we want to do. So those are test conditions. Popular tests. Oops, too far. The tensile test, which yields the stress-strain curve, which is on page 34 and 35. You might tab those pages. Our tensile test yields our stress-strain curve, which gives us some points on the curve, gives us some information about the mechanical properties. I won't ask anything about guided bend tests. Hardness testing, we did hardness testing, and understanding the Rockwell scales. So we had HRB for softer materials, and we had HRC for harder materials. Chapter 11. Questions on making steel? No. Nothing there. So different levels of deoxidization. This understanding what these are here, not intimately, but killed and semi-killed are the important ones, because these are 99% of the materials that you guys are using are either killed or semi-killed. So just knowing the definition of those two levels of deoxidization. Nothing here. AISI steel designation, page 183 in your book. Definitely want to tab that page. There will be questions on identification. So I might give you something like 4140. I'm going to ask you 3 questions about that, right? I'm going to ask you the class or family, and I'm going to ask you alloy content, and I'm going to, which is going to be percent of each element, which is listed on page 183 in your book, and then I'm going to ask you carbon content. And that'll be a percentage also, right? So in 4140, we know that this is point. We know this is 0.40% carbon. Keep pressing buttons here. So these are the 3 things that I'm going to ask you, and there will be a couple questions about material designations off that page. Make sure that you tab that page for sure. Chapter 12, carbon steels, crystal structure. I would be able to